All right, today we're going to be talking about adding and subtracting fractions, beginning by adding and subtracting fractions with the same denominator and eventually moving to more difficult problems that have different denominators. But to begin with, what I want to think about is thinking about fractions as slices of pizza, because we all like pizza. So if we have a pizza that we split up into 4 pieces. Okay. And say we want to eat some of this pizza, and we eat, to start out with, we eat 1 slice. Okay. So when we think about fractions, right, we're always thinking about parts out of wholes. Okay. So we've eaten 1 slice of pizza out of a total of 4 slices, because we have 1, 2, 3, 4 total slices. Okay, and then let's imagine that we're still hungry, and so we eat 1 more slice of pizza. All right, and so that is 1 more slice that we've eaten out of still the same 4 slices. Okay, so let's think about if we add these together, right? So if we add these together, this becomes 2 full slices out of 4. So in total, we have eaten 2 slices out of 4. All right. So this is sort of the heart of adding fractions, is that we want to think parts out of wholes, and this is the reason that when we add fractions, we keep the denominator the same. So what you'll notice is that we add 1 plus 1, which gives us 2, but the 4 stays the same on the bottom. So we do not change the denominator. Okay, and the reason is because we're still out of 4 pieces. 1, 2, 3, 4. So we have 2 out of 4 that have been eaten. So nothing really changes with the denominator in terms of what it is out of. Okay, so having thought about it that way, let's split up our fractions slightly different. And I want you to try this on your own. So if we have 1/3 plus 1/3, what's that going to equal? Try to figure this out, and if you need to, we can draw some pizzas. All right, so as we said, we can do this a couple ways. First, let's just do it kind of the straightforward way of just saying, okay, just add the top. So 1 plus 1 gives you 2, and then we keep the denominators the same. So we have 2 out of 3, and that's our answer. 1/3 plus 1/3 equals 2/3. Now we can think about this as pizza. Okay, so that would be 1 slice of pizza out of 1, 2, 3 slices. Another 1 slice of pizza out of 1, 2, 3, and that gives us 2 slices eaten out of a total of 3, 2/3. Okay. Now, we can also use this sort of pizza metaphor to think about how to begin adding fractions that have different denominators. Okay, so say we have a pizza that is again cut into 4 slices. Okay, and then another pizza that is really, we'll think about it as the same pizza, but it's sort of cut differently. Right, now we're just cutting this into 2 slices. All right, now we come again and we eat 1 slice out of here. Okay, so that is, as we said last time, that is 1 out of 4 total slices. And then we are going to add to that 1 slice from the pizza that's just cut into 2 slices. And what you should immediately notice is that 1 slice in this pizza is bigger than 1 slice over here, because it's 1 out of only a total of 2 slices. Okay? Now, we can't just go ahead and add these together, right? Because our denominators are not the same. So this is important. We can't add fractions if they have different denominators. We have to make them have the same denominator. So what you should probably notice is that, hey, yeah, this is 1 out of 2, but what if we just cut this pizza into more slices? All right, so now we have a total of 4 slices, so that's good, right? So this gives us a new fraction where we have a total of 4 slices, but you should notice that our part, right, is now 2. Okay, so what we've done is we've made 1/2 into 2/4, and these are actually the same. These are equivalent fractions. We'll be going over equivalent fractions here in a second, but just make note that these are equivalent fractions. It means the same thing. You are eating the same amount of pizza, whether it's 1/2 or 2/4. Same amount, just different number of slices. Okay, this gives us a final answer of 3 out of 4, or 3/4. So 1/4 plus 1/2 gives us 3/4, but along the way we needed to change 1/2 into 2/4, and these are the same because this gives us the same denominator. Okay, so let's move on to trying to do a couple practice problems on your own of adding fractions with the same denominator. So let's do 2/5 plus 1/5, and then 1/8 plus 5/8. Then we'll do some subtraction as well. So 7/10 minus 5/10, and 5/6 minus 2/6. All right, give those a try on your own. All right, so hopefully you tried those on your own. Now we just add the tops. So this becomes 2 plus 1 is 3, and then the denominator stays the same, so that's 3/5. Again, add the tops. 1 plus 5 is 6. Keep your denominator the same, so it's 6 out of 8. Okay, same with subtraction. Just subtract the top, so 7 minus 5 is 2, and then denominator stays the same, 2 out of 10. Okay, again, top stays the same, so that's 3 out of 6. So 5 minus 2 is 3, and then your 6 stays the same. Okay, now I'm sure some of you are thinking, now wait a minute, these fractions are not simplified, and you're exactly right. We would need to simplify these in class, and in the next portion of the video we will go over simplifying. But if you want a little preview, we can go ahead and simplify these, right? So 6/8, right? We can simplify down, and we can divide by each one by 2, right? And this would become 3 out of 4, and that would be our final answer. Same thing here. We can divide each of these by 2. Divide by 2. Divide by 2. And then this would give us 1 out of 5. And then same thing here. We can actually divide by 3 here. This would give us 1 out of 2, or 1/2. Okay, but again, don't worry if you're not understanding this. We'll go over simplifying fractions here in a second in more detail. But these would be our final answers. All right, moving right along. Now, when we are adding and subtracting fractions with different denominators, we can't always make pizzas and draw bar models and things like that I'm sure you've done in class. Sometimes we just don't have enough time, or we just have fractions that are too big to deal with that, right? To have that many pieces of pizza just gets kind of unreasonable. So what we want to do in order to get the same denominator, right? Basically, we want to begin thinking about equivalent fractions. Okay, so equivalent fractions are simply fractions that are equal to each other but look different. In the previous part of this video, we talked about how 1/2 was equal to 2/4, right? Because it's the same amount of pizza, right? 1/2 of a pizza is the same if we just cut this into 4 slices. So it goes 1 out of 2, now it's 2 out of 4. All right, so that is equivalent fractions. Now, how do we get equivalent fractions? Again, if we don't want to just continue drawing pizzas. So what we can do is let's take again 1/2. And let's think about what we do when we go from 1/2 to 2/4. How are we getting from here to here? Well, what we're actually doing is we're just taking 1/2 and we're multiplying it by 2/2. Okay? Now the reason we're allowed to do this is because 2/2 is simply equal to 1 whole. Okay? Because you have 2 out of 2. You've eaten 2 slices of pizza out of 2 pieces. So that's 1 whole pizza. Okay? So anytime we multiply a number by 1, it simply equals itself. So we're allowed to do this. Okay? So the golden rule here, okay, is whatever you do to the top of a fraction, you have to do to the bottom. Whatever you do to the bottom of a fraction, you also have to do to the top. If you follow this rule, okay, then you can kind of go on forever. All right, so let's try that. Let's try if we just go, all right, multiply by 2 again, multiply by 2 again. And that gives us now 4 out of 8. 4 out of 8. Okay, and you can keep doing this on and on and on. Okay, so as long as you multiply the top and the bottom by the same thing, it can just go on forever. Now you can also think about this as sort of skip counting, which I'm sure you have done in class, and we can just skip count for both of these numbers. So let's try that actually, because sometimes it can help us understand it a little bit more clearly. So if we skip count, right, 1, 2, 3, 4, 5, 6, right? We're just counting. And then on the bottom, we're counting by 2s. 2, 4, 6, 8, 10, 12. And again, this goes on forever. So there are actually an infinite number of ways that we can write 1/2. Starting with 1/2, then we can just keep going on and on and on. Okay? So I want you to try that actually on your own, except starting with 3 as your denominator. Okay, so if we started with 1/3, okay, and we did some skip counting, what would that give us? So try, go for, let's say 5. So try that on your own. Okay, hopefully you tried it on your own, and what you'll see is we're counting by 3s on the bottom and 1s on the top again. So we have 1, 2, 3, 4, 5 along the top, and then on the bottom we have 3, 6, 9, 12, 15, so on and so forth. All of these are equal. Again, it goes on to infinity. And again, we're just counting by 3s on the bottom. Okay? So this is another way we can think about equivalent fractions. And on the top, we're counting by 1s. All right, so on and so forth, okay? Now, don't be confused by this, right? Because I know I said whatever you do to the top, you do to the bottom. This is only for multiplication and division that rule applies, because really you are doing that, right? You're multiplying. We could think about it as adding 1, right? But we can also think about it as multiplying by 2. Multiplying by 2, right? So 1 times 2 is 2. 3 times 2 is 6. So when whatever you do to the top, you do to the bottom rule is when you multiply or divide. So make sure you keep that in mind. Okay, so let's try to do some equivalent fractions, not by skip counting this time, but instead by doing our rule, whatever you do to the top, you do to the bottom. So say we have 2 out of 7, okay? And we want to get a fraction that's equivalent, but we have kind of a mystery number here on the bottom, right? So we don't know our denominator, okay? And then on the top, we have 6, okay? So see if you can figure this out. Okay, so how do we get from 2 to 6? What do we need to multiply by? Well, we need to multiply 2 by 3 to get 6. All right, and whatever we do to the top of a fraction, we do to the bottom. So we also multiply the bottom by 3. 7 times 3 is 21. Okay, so that means 2 out of 7 is the same as 6 out of 21. All right, let's try one more. So say we have 5 out of 15. is equal to a mystery number up top, okay, out of let's say out of 3. Okay, give it a try. Okay, what you should notice is that this is a little bit different, right? Because we're used to multiplying to get it, right? And what you should see is that to get from 15 to 3, we are actually getting smaller, okay? So we can also use division here. So what do we need to divide 15 by to get 3? Well, we need to divide 15 divided by 5. You can also think 3 times 5 equals 15, right? So if we divide by 5, we also need to divide the top by 5. 5 divided by 5, any number divided by itself, right, gives you 1. So 5 out of 15 is equal to 1/3. Okay, and that would actually be how we reduce this fraction as well. All right, let's do another one. So let's do something out of something. Go over here so we have a little more room. Something out of 3. We don't know. Mystery number is. Actually, let's do something bigger. Let's step it up a little bit. Let's do something out of 18 is equal to 1 out of 9. 1 out of 9. Give it a try. Okay, what you should see is that we need to get from 18 to 9, we need to divide by 2. Okay, or you can think about it the other way and think, okay, we need to multiply 9 by 2, right? So 1 times 2 is simply 2. So 1/9 is the same as 2 out of 18. All right, let's do one more equivalent fraction problem here. Let's do 9 out of a mystery number is equal to 27 out of 45. We'll get a bit higher here with them. Give that a try. All right, to get from 27 to 9, what do we need to do there? Well, we need to divide by 3 because 9 times 3 gives you 27. So 45 divided by 3 is going to give us 15. So 27 out of 45 is the same as 9 out of 15, and you could actually keep reducing that. Okay, so let's try to use our skills with equivalent fractions to help us begin to add and subtract fractions that have different denominators, Okay, so say we have 1/4 plus 5/8. All right, so as we see, these do not have the same denominator. All right, so 1/4 plus 5/8. We need to get the same denominator. How do we do that? Well, a lot of times with these fractions, and this isn't always going to be the case, as we'll go over later, is when we have something like 4, which clearly goes into 8, right? Then what we can do is come down here and say, okay, 1/4 is equal to what? Our mystery number out of 8, right? So we just have an equivalent fraction problem. Well, we need to multiply by 2, and that's going to give us 2 out of 8. So we need to replace 1/4 with 2 out of 8. So let's go ahead and do that. So we have our new problem, which is going to be 2 out of 8, 2/8 plus 5/8 is equal to 7/8. All right, and that's our answer. So we changed 1/4 into 2/8, and that allowed us to then add our fractions. All right, let's try another one there. So let's try 5/6 minus 2/3. We'll do some subtraction. So 5/6 minus 2/3. All right, give this a try. All right, so what you should see is that 5/6, 2/3 do not have the same denominator. So we need to make 2/3 equal to a mystery number up top and a 6 on the bottom. So how do we get from there to there? Well, we need to multiply 3 times 2 and 2 times 2. So 2 times 2 is 4. So that means 4/6 is the same as 2/3, so we can replace that. All right, so our new problem will be 5/6 minus 4/6. Okay, again, we just took 2/3 and replaced it with 4 out of 6. And that gives us 1/6. And 1/6 would actually be our final answer. Okay, so using equivalent fractions, we can add and subtract fractions with different denominators. Okay, let's do 2 more on your own, and then we will move on to reducing fractions. So if we have 3/10 plus 2/5. All right, give that a try. So what we're going to do is we're going to take 2/5 and we want to make it something out of 10. So we need to multiply the bottom by 2 to get there. So we also need to multiply the top. Remember, whatever you do to the bottom, you have to do to the top. Whatever you do to the top, you have to do to the bottom. So we get 4 out of 10. Our new problem, therefore, is 3 out of 10, 3/10, plus 4/10. Okay, is equal to 7/10. That's our answer, 7/10. Okay, we took 2/5 and replaced it with 4/10. All right, and one more. Let's do a subtraction. So 7/9 minus, let's do 7/9 minus 1/3. Give that a try. Okay, so we need to get 1/3 to have a denominator of 9. So how do we get 3 to become 9? Well, we need to multiply 3 by 3. So whatever we do to the bottom of the fraction, we also have to do to the top of the fraction. So 1/3, 1 times 3 will become 3 out of 9. So our new problem is going to be 7/9 minus 3/9. Okay, 1/3 becomes 3/9. And that equals 4/9. So again, we just subtract 7 minus 3 equals 4. And then your denominator stays the same. Okay, so the big concept to keep in mind here, because this can be abstract sometimes, is that when we replace and transform 2/5 into 4/10, right? This is the same value, okay? And 1/3, 3/9. These are the same value. It's just a different way of representing the same amount, okay? Again, pizza is always the best way to think about this, right? If you have a big pizza and you cut it into 5 slices and you have 2, that's the same amount as if you cut it into 10 slices, because the slices get smaller and smaller as you cut them, right? And then that becomes 4 instead, all right? So if we visualize that real quick, right? We have 3 slices. Then if we want to make it 9, right, we need to cut each of these into 3 slices. Okay, now it's not perfect, but you see how the slices keep getting smaller and smaller the more we cut them up. All right, now real quick, let's use our knowledge of equivalent fractions to reduce fractions, okay? So say we have something like 20 out of 25, okay? And this is what's called not simplified, okay? And what we want to think about is, do these numbers have any factors that in common? So is there a number that goes into 25 that also goes into 20, okay? And what we should say is, yes, we do, okay? We have 5. So we can divide both of these by 5 and end up with whole numbers, okay? So 20 divided by 5, whatever you do at the top, okay? 20 divided by 5 is 4. 25 divided by 5 is 5. And this is okay, because whatever you do to the top, you do to the bottom, so we're good to go. So 20 out of 25 is 4/5. All right, so let's try one of those on your own. So 12 out of 28. What's that going to equal? All right, so let's try this. So what you should see is, you might have thought, well, I know these are both even, so why don't we divide it by 2? All right, well, what happens if we divide it by 2? We get 6 out of 14, okay? That's totally cool. These are still the same, right? But what you should notice is that this is actually not fully reduced yet, because 6 out of 14, again, 2 goes into that again. So we can continue going. And then we get 6 divided by 2 is 3. 14 divided by 2 is 7. And now we say, oh, that's sort of the end, right? We can't keep dividing by anything to get us smaller and smaller. So our answer is 3 out of 7. And this is an okay way, it's just not as fast, but it is fine to reduce in this way. Just keep dividing by a number that you know until you get to the answer. Now, you could have done this faster, right? By doing 12 over 28 and then going ahead and dividing by 4 at the very beginning, okay? And then that would give us 3 out of 7, okay? And the reason that is because 4 is what's called the greatest common factor, okay? And but you don't actually have to do that, right? As I said, you can just do it in steps. But if you go ahead and divide by the greatest common factor, it saves you time. Okay, let's try another one on your own. So if we have 25 out of 35, okay? Try to find the biggest number that goes in before you divide. Okay, so hopefully you saw these both end in 5, so 5 is a pretty big number, so maybe 5 is the greatest common factor. And in fact, you are correct. 25 divided by 5 gives us 5. 35 divided by 5 gives us 7. So 5 out of 7 can't go any further, so we are simplifying, okay? So this is how we use equivalent fractions in our rule. Whatever you do to the top, you do to the bottom in order to simplify or reduce fractions. Okay. So let's get to how we add and subtract fractions with different denominators, okay? When we have fractions that don't necessarily become equivalent as easily as some of the other ones we've been looking at, okay? Now, a great example of this is 1/2 plus 1/3, okay? Because what is different about these, right, is if we come down here and say, okay, 1/2, and I want to get something 3. Well, we can't really multiply anything super easily without getting kind of weird fractional multiplication to get from 2 to 3, okay? Same thing, we can't really get from 1/3 to something out of 2 super easily, right? So this strategy doesn't actually work every time, as we see. So what we have to do in this case is find what's called the least common denominator, or you may have heard in class this called the least common multiple, okay? Multiples, okay, multiples are just when you basically skip count, okay? So if we skip count by 2, we have 2, 4, 6, 8, 10, right? And then let's skip count for 3. 3, 6, 9, 12, 15. And this could go on forever, right? But usually it's actually a good idea to just do maybe 3 to 5 at a time, right? Really 3 at a time is good because you might get a match, okay? And what you're looking for in order to find the least common multiple, okay, we need to find the number that they have in common that's the smallest. Okay, so 6 is what they have in common. Okay, again, let's think about that phrase, least common multiple. Like a lot of things in math, okay, the names of these things, right, can seem a little advanced or fancy, right? But it's very descriptive, right? It's the smallest number, the least, okay? The smallest number that are multiples, okay, for skip counting, that they have in common, that they share. So this is 6, okay? So this means we need to change both of these fractions, okay? So we'll start with 1/2. So what would 1/2 equal with a denominator of 6? Well, whatever we do to the bottom, we need to multiply the bottom by 3, okay? We do to the top. So 2 times 3 is 6, so 1 times 3 is 3, okay? So our new fraction is 3 out of 6. Let's do the same thing with 1/3. So 1/3 is equal to, all right, well, what out of 6, right? Because we both want to get both of them out of 6. So to the bottom, we multiply this by 2. Whatever we do to the bottom, we also have to do to the top. So our new fraction is 2 out of 6, because 1 times 2 is 6. So our new problem, therefore, is 3/6 plus 2/6 is equal to 3 plus 2 is 5, and then our denominator stays the same, 5/6. And that is our answer. 1/2 plus 1/3 gives you 5/6. You just have to change 1/2 into 3/6. Then you have to change 1/3 into 2/6. Now again, the way that we knew to use 6 is because this is the smallest number that they have in common. So it'll work. All right. Now this is a long process, but I want you to try one of these on your own. So let's do 4/5 plus 1/3. All right. See if you can figure that out on your own. Okay, so what we should have done to start is say, all right, what are the multiples of these numbers? All right, so let's do that. Let's do 3 at a time. 5, 10, 15, and then we have 3, 6, 9. Any in common so far? Not yet. Now, one trick is that we're at 9. That's a lot smaller than 15. So if you keep going like back and forth, right, it actually wastes time. So let's try to catch up in case there's a match. So let's do a couple more. 12, 15, and indeed, we did have a match there. So we have 15, and you don't need to go any further, right? Once you have a match, you're kind of all done. So that means our least common multiple, or our least common denominator, is 15. All right, so let's get our new problem. Well, we have 4 out of 5, and we want to make that have a denominator of 15. All right, so what did we need to multiply 5 by to get 15? We needed to multiply by 3. So 5 times 3 is 15. Whatever you do to the bottom, you also do to the top. So 4 times 3 is 12. So our new fraction is 12 out of 15. All right, now let's take 1/3. And how do we get 1/3 and have a denominator of 15? Well, we need to multiply 3 by 5. Now, whatever you do to the bottom, you also do to the top. So 3 times 5 is 15. 1 times 5 is 5. So our new fraction is 5 out of 15. So this leads us to our new problem, which is going to be 12/15 plus 5/15. 12 plus 5 is 17. And then the denominator always stays the same, so 17/15. And this is actually our answer. Now, you probably will notice that our numerator is bigger than our denominator, okay? This is what's called an improper fraction. There's another video on this. We're not gonna go over this right now, but just know that this is called an improper fraction. And another way that you can write this is using a mixed number, which is 1 and 2 out of 15. But again, this is gone over in another video, so we'll save that for that context. But again, all we did here is we made 4/5. We changed it to 12 out of 15. And then we took 1/3 and changed it to 5 out of 15. And this gave us 17 out of 15. Okay. Let's do a subtraction problem. So say we have 3/4 minus 2/5. Try that on your own. All right, so hopefully we said, all right, what are our multiples of 4? Well, we have 4, 8, 12, 16, okay? What about 5? 5, 10, 15, 20, Okay, nothing yet. Let's do one more up here. Up 20. There we go. And you can begin to see how you can get a feel for how these work, right? Where it's sort of like you're catching up, one's catching up to the other, and you can get a feel for if you're about to reach one. And you can also, the more you do this process, the more you will begin to be able to do it in your head without actually listing them. But we have 20 as our least common multiple, or least common denominator. Okay, so let's transform this problem. And we need 3/4 to become something with a denominator of 20. All right. Let me make that 3 a little neater up here for you. 3. Okay, so what do we need to multiply 4 by to get 20? We need to multiply it by 5. So 4 times 5 gives you 20. Whatever you do to the bottom, you have to do to the top. So 3 times 5 is 15. So that's our new fraction there. And then we also have 2/5 is equal to something, again, out of 20. What do we need to multiply to get 20? 5 times 4 gives you 20. So whatever you do to the bottom, you also have to do to the top. 2 times 4. 2 times 4 is 8. All right, so our new problem is 15 out of 20, 15 twentieths minus 8 twentieths. Okay, now we just take our tops, subtract, so 15 minus 8 gives you 7, and then our bottom stays the same, 20 stays the same, so 7 twentieths. And that is our answer. So 3/4 minus 2/5 is 7 twentieths. And again, all we did was we took 3/4 and transformed it into 15 out of 20 with our equivalent fractions. And then we took 2/5 and transformed it to 8 twentieths using equivalent fractions. And this gave us a new problem where we have the same denominator, and then therefore we can subtract. And we got 7 twentieths. 7 twentieths. All right, let's do one more problem. And let's do one where our denominator gets a little bit higher. So 5/7 minus 1/4. Give that a try. All right, so we're going to come down here. We're going to count by sevens. 7, 14, 21. Okay, now we should already be thinking, right? Hey, this is one great example of where we kind of want to catch up, don't we? Because our 4 is going to go up by a lot less. Okay, so let's go ahead and do that. Let's catch up. 4, 8, 12, 16. See, we still haven't caught up. 20. Now we've caught up, right? So it took us 5 to catch up to the 3. That's a great way to do it. It's kind of a feel thing here. And then we have 21, 28. All right. And then 35. Let's catch back up. 20, 24, 28. Always be looking for the match, and indeed we do have a match there. It's 28. Okay. So this gives us a new denominator of 28. So 5/7 we need to have a denominator of 28. So we need to multiply the bottom by 4. 7 times 4 gives you 28. So you also need to multiply the top by 4. Whatever you do to the bottom, you have to do to the top. So 5 times 4 is 20. So we have 20 out of 28. And then we have 1/4 is equal to, all right, well, something out of 28. So what do we need to multiply 4 by to get 28? We need to multiply 4 by 7. So whatever you do to the bottom, you have to do to the top. So we multiply the top by 7. So 4 times 7 is 28. 1 times 7 is 7. So our new problem is 20 out of 28 minus 7 out of 28 is 13 out of 28. And that's our answer. So 5 out of 7, 5/7 minus 1/4 is 13 28ths, okay? Now, this can look a little weird, right? Because we have very different numbers here, all right? But again, it's the only way that you can do it is you got to keep splitting the pizza up into more and more slices in order to compare them and in order to add and subtract them. So 5/7 becomes 20 out of 28. 1/4 becomes 7 out of 28, and then we get 13 out of 28 as our final answer. One thing that some of you may have noticed is that a lot of times you're just multiplying 7 and 4 to get your denominator of 28. And that is true, that does work. There are some examples, and I'll show you real quick one of them, where it's doing that will kind of get you a fraction that's overly big, and it'll waste some time. So if we have 1/6 plus 5/8, for example, if we do 6 times 8, that's 48. So that would give us a denominator of 48, which is overly big, because if you do your multiples, we'll have 6, 12, 18, 24, and then we have 8, 16, 24, right? So we can actually have a denominator that's half as big as 48. Here, that's 24. That's just going to make our lives a little bit easier, so we're not dealing with such huge fractions. And I'll let you continue this on your own. So what we'll get is 1/6 will become, right, what out of 24? Well, we need to multiply 6 times 4. Times 4, whatever you do to the bottom, you do to the top. So this becomes 4 out of 24. Same thing, 5/8. We need to get a denominator of 24. So 8 times 3 times 3. 5 times 3, 15. Our new problem is 4/24 plus 15/24. And that gives us 19/24. That's our answer, okay? If you had done it with 48 as your denominator, you would have gotten basically things that are unnecessarily big, right? So you have 38 out of 24, or sorry, 38 out of 48. And then you need to divide top and bottom by 2 in order to reduce, right? So then that would give you 19 out of 24. Okay, it's just an extra step, and it's not necessarily needed, and it's good to be consistent in the way you do it. Okay, again, one last time, all we did here was we made 1/6 into 4 out of 24, and we made 5/8 into 15 out of 24, and that gave us 19/24 as our final answer. All right, hope that helped. Now you should be able to add and subtract fractions no matter the denominator using this method. All right, thanks.